Okay, I'm back, and so what I've done is I wrote down that formula here. Spring constant, how far did the spring stretch, and then mass that you were hanging from the spring, and then 9.81. And then you were to solve this thing for the letter C. So the M that you're going to use for here is going to be 150 grams. And then you want to convert that to kilograms. So that's going to go here. So you see that what I've done was I changed the mass up here until it was 150 grams. Okay, now I didn't do anything to this one here. So I can change the spring constant by moving this slider, but we're not going to do that. Another thing I did was I got out my timer. So here's the timer. Here's a ruler so that I can measure everything, but I don't really need the ruler anymore. So if I wanted to, I could put the ruler back. So I just need the stopwatch. So what I'm going to do is, now that I have calculated my C, I'm going to take it, and it is going to go right there. Okay, my M, I'm still going to be using the 150 grams converted to kilograms. So still use that same number for that one right there. Okay, we're going to take this thing and we're going to pull it down. We're going to let it go. Okay, and then I need to time it so when it gets to the bottom, I'm going to click my stopwatch. Okay, and then I'm going to start counting. And then when I get to 10, so let it bob up and down 10 times, and when I get to 10, I'm going to click it off, and then I'm going to do it 3 times, and then take the average. So then you could plug it into this formula up here and get your measured frequency of the spring. Okay, then you're going to calculate the frequency of it because you know the C from the previous thing that we just did, and you know the M, so we set it to be 150 grams, but convert that to kilograms, and you're going to get a frequency. Hopefully these two numbers will be the same. All right, now I also want you to go explore this a little bit more. So let's go back to the lab here. So the whole purpose of filling out this big chart is so that you can compare the measured frequency using this one with the calculated frequency using this one. Okay, so question 10, what should happen to the frequency of the spring if a larger spring constant is used? So i.e. a stiffer spring. So look at this formula. What do you think happens if the top part of a formula gets bigger? If the bottom part of a formula gets bigger, what comes out gets smaller. But the C is on the top. Okay, then I want you to verify that by changing the spring constant on simulation, and then pulling it down, letting it go, and then observing did the frequency go up or did the frequency go down. Okay, then 11 is what would happen to the frequency of the spring if the mass is increased. So this time, if you make M bigger, then what comes out of the formula? And then I want you to verify that using the simulation. Then number 12 is what's going to happen to the frequency if the spring is pulled down further. So you notice I didn't tell you how far down you need to pull it and then let it go. So you're going to get a certain frequency if you pull it down a certain distance, but now this time pull it down even further and let it go and just see what happens. All right, so now that's the lab, and then it's time to do your post-lab questions. So I put in here, like for example, question number 5. What is the frequency of that spring if it bobs up and down 30 times in 2 minutes? Now 2 minutes is the wrong unit. You need to convert that to seconds, and then you can calculate the frequency using this formula up here. Okay, then I give you a pendulum that has a length of 0.5, calculate its frequency. So use the formula for the pendulum, not this one, so this is for the spring, but go back to the formula for the pendulum and calculate its frequency. All right, so that's your lab. So I hope you enjoyed that as much as I did explaining all that to you. So that's our lab for today, so have at it, and I will see you next time.